What happens when AI systems start improving themselves? When super resolution models are judged by real world downstream impact, and when code generation is exposed as a carrier of social bias. In this episode, we dive into three striking new papers that push AI beyond surface level metrics and into the messy realities of adaptation, utility, and fairness. From self evolving coding agents to remote sensing benchmarks and bias mitigation frameworks, these studies reveal both AI's rapid progress and the hard problems that still remain. Let's explore the first paper, Agentic Harness Engineering Observability-Driven Automatic Evolution of Coding Agent Harnesses. AHE turns harness optimization into an observability-controlled self-evolution loop over NextAU, a coding agent framework with explicit file-level components. Starting from a minimal bash-only seed, it exposes 7 editable surfaces: system prompt, tool description, tool implementation, middleware, skill, sub-agent, and long-term memory, then distills million token rollout logs into layered evidence and binds every edit to a next round falsifiable prediction. On terminal bench, 2's 89 tasks, 10 iterations raised pass at 1 from 69.7% to 77%, beating Codex CLI at 71.9%, and self-evolving baselines ACE at 68.9%, and TFGRPO at 72.3%. The gain transfers without re-evolution. On SWE bench verified, it reaches 75.6% aggregate success, with 461K tokens per trial, 12% fewer tokens than the seed, and on 3 alternate base families, it adds plus 5.1 to plus 10.1 percentage points, including plus 10.1 on DeepSeek, V4, Flash, and plus 6.3 on Quinn, 3, 6, plus. Ablations show the improvement lives in tools, middleware, and long-term memory. The system prompt alone regresses by 2.3 points, implying that executable harness structure transfers better than prose-level strategy. The paper's main novelty is not prompt refinement, but making harness edits explicit, revertible, and attributable through component observability, experience observability, and decision observability. It also shows a limit. Self-attribution is strong for fixes, with 33.7% precision and 51.4% recall versus 6.5% and 10.6% random, but weak for regressions, only 11.8% precision and 11.1% recall, which explains non-monotone evolution steps and motivates regression foresight as the next key problem. Let's explore the second paper, Beyond Visual Fidelity Benchmarking Super Resolution Models for Large-Scale Remote Sensing Imagery via Downstream Task Integration. Beyond Visual Fidelity argues that remote sensing super resolution should be judged by downstream utility, not only PSNR, SSIM. The authors introduce GeoSR Bench, a task-integrated benchmark built from spatially co-located, temporally aligned, cloud-filtered image pairs spanning roughly 36,000 locations and about 9.3 million kilometers squared, with 2 cross-platform SR settings: Modis 500M to Landsat 830M and Sentinel 210M to NAIP 0.6M. The benchmark also includes 10 pixel-level downstream datasets, about 16,000 label-aligned triplets covering semantic segmentation and regression for rivers, urban land cover, cropland, GPP, canopy height, buildings, roads, and tree finder-style sub-pixel tree mortality. They evaluate 9 steradians models across GAN, transformer, neural operator, and diffusion families, including ATD, RGT, CFAT, CA Mixer, SRNO, BiDiff, UPSR, CED, and ESRGAN, plus downstream models UNet, SegFormer, and Mask2, Former, yielding 270 experimental paths. The key result is that fidelity and utility often diverge. Higher PSNR, SSIM frequently fails to improve downstream performance, and correlations can be negative, especially among top-ranked competitive models. Transformer and neural operator SR methods usually score best on PSNR, SSIM, while GAN and diffusion methods often produce sharper-looking outputs but lower fidelity scores. Downstream task gains are task-dependent. On Modis, 2, Landsat, 8, SR improves some F1 scores by up to about 10%, but often remains far below the Landsat 8 upper bound. Regression tasks benefit more consistently. On Sentinel, 2, to NAIP, CED recovers more than 50% of the gap on road detection and shows some of the largest gains, yet substantial gaps to NAIP remain. For subpixel targets like Tree Finder, SR offers only marginal 0.4% gains, exposing a hard limit of SR when the object is smaller than the source pixel. Let's explore the third paper, Social Bias in LLM-Generated Code, Benchmark, and Mitigation. This paper argues that LLM code generation inherits social bias as executable logic, not just text. The authors build Social Bias Bench, a benchmark of 343 neutral, human-centered coding tasks spanning 7 demographic dimensions: age, gender, race, religion, marital status, education, employment status, and socioeconomic context. They pair it with Solar, a metamorphic testing framework that auto-generates class-based Python prompts and executable fairness tests by varying only one protected attribute at a time, then scores outputs with Code Bias Score, CBS, Bias Leaning Score, and PAS Arrow-Bayes attribute. Across 4 models, GPT, 3, 5, Turbo, 0125, CodeChat Bison, at 002, Code Llama, 70B, Instruct, HF, and Claude, 3, Haiku, 202-40307. Bias is pervasive, with overall CBS ranging from 28.34% to 60.58%. GPT, 3, 5, Turbo, 0125 is worst at 60.58%, while Code Llama is lowest at 28.34%. Bias is model-specific in direction. For race, different models lean toward different groups, and bias severity is temperature-sensitive but non-monotonic, with Code Llama rising from 28.5% at temperature 1 to 65.19% at 0.2, prompt-level mitigations fail. Chain of thought increases GPT-3, 5, CBS from 60.58% to 72.65%, and a fairness persona plus CoT still worsens bias in most models, showing that reasoning prompts expose stereotypical associations rather than suppress them. Structured multi-agent workflows help only when early roles properly scope attributes. In Flowgen Waterfall, CBS drops to 24.49%, but adding fairness instructions to all roles raises it to 31.06%. Removing the requirement engineer causes the worst bias, 36.97%. The main contribution is FMA, an Oracle-free fairness monitor agent that classifies task attributes as required or restricted from the docstring and types, then iteratively reviews and rewrites code without test suite access. On all 343 tasks, FMA cuts CBS from 48.4% to 16.91% after 3 rounds, a 65.1% reduction, while pass that attribute improves from 75.8% to 83.97%. That's a wrap on today's AI paper highlights. Thanks for watching.